Greetings. Welcome to the Society of African Earth Scientists Solar Photovoltaics Power Installation video. We'd like to install a 24 volt home solar power system. It consists of four main components. First, the charge controller, the batteries, the pure sine wave power inverter. The charge controller is 12/24 volts. It's a 24 volt system. The batteries are three 12 volt deep cycle marine batteries, and the power inverter is a 2000 watt 24 volt pure sine wave power inverter. The fourth component, if we follow the trail of the wires, is the two 12 volt 150 watt solar panels. These are arranged in series. We connect the positive terminal from one panel to the negative terminal to the other panel, and we get a series connection so that these two 12 volt panels make a 24 volt panel arrangement. The remaining terminals give us the positive and negative leads of the solar power array, and they lead to the charge controller. So the positive and negative lines from the panel lead into the positive and negative terminal of the charge controller, and we can see that the panels are charging the battery. We see 33.7 volts and a small direct current of 0.6 amps. To power the charge controller, we have to connect the charge controller to the batteries. So we connect the positive and negative wires from the charge controller to the negative and positive wires of the battery. Negative to negative, positive to positive. We have a 3 battery array, but we're going to try and create a 24 volt system. We connect 2 of the batteries in parallel by connecting the positive of one to the positive of the other, the negative of one to the negative of the other, making a connection in parallel, and you get 2 12 volt batteries in parallel, making a larger capacity 12 volt battery. You've got another lone 12 volt battery, and this is connected to the larger capacity 12 volt battery in series by connecting from the negative of the lone battery to the positive of the larger capacity battery. And this series connection gives us a 24 volt battery arrangement. Now the sine wave inverter is respectively connected to the negative and positive terminals of the battery, making sure we do not reverse sine, as this will damage the equipment. The sine wave inverter has got a round pin plug which we can attach to a plug board like this, and then we can plug in our appliances, our computer, fridge, whatever we like. So we see that we've got a green light, 34.3 volts, shows us that the battery is charging. We've got a small direct current of 0.5 amps, and everything is working fine. So, to summarize, we've just demonstrated the installation of a simple 24-volt home solar power system. It consists of 4 main components: the solar panels, which are outside, our charge controller, our 12 to 24-volt charge controller, a 24-volt battery, which is made up of 2 12-volt batteries connected in series. We've got a power inverter, a 24-volt power inverter, and that provides a conversion from direct current to alternating current, AC, so that we can plug in our household appliances. And en route to the positive connection from the charge controller to the battery, we have entered or included a fuse. So if we see here, from the positive terminal to the battery, if you see, in a convoluted way, we've included a 20 amp fuse, and this is there purely to protect our equipment. So that completes that. And also, in relation to the solar panels, to connect 2 12-volt solar panels in series, we made a connection from the positive of one panel to the negative terminal of the other, and that gave us an overall 24-volt solar panel array, with the outstanding terminals being the negative and positive wires, which then led to the negative and positive terminals of our solar charge controller. As we see, the light is fading as it's about 7 in the evening. We've got 0.5 amps, 31.2 volts, the battery is still charging, the light is green, so the panels are working well. We haven't yet turned on the inverter. Now, if we switch on the inverter, if we get a red light, that means there's a fault and we haven't set it up correctly. And the red light will be accompanied by a number of beeps. Depending on the number of beeps, we can analyze the fault by reference to our product manual. But let's hope we don't have to do that. Okay, we've got a green light. Everything is fine. We can assume that the power inverter is ready to convert direct current from the batteries, which are being recharged by the solar panels, to alternating current, which we can use for our household appliances. And that's that. That completes our solar installation demonstration.